Hi everyone, good evening. Hi Anjali, hi Siddhi. Evening Pratmesh, evening Prateek. Hi Rudra. Wish you guys a happy new year. Hi Sanika. Hi Pratmesh. I hope you guys had a good time. किसी ने कुछ इंटरेस्टिंग करा न्यू ईयर्स ईव पे? सब घूमने फिरने में गए या फिर पढ़ाई कर रहे थे? ऑलराइट, वी हैव हॉकी प्रैक्टिस. क्या बात है पार्थ, मतलब तुम तो एकदम. अनुषा ने केक खाया. सुमित नाइट आउट मारा. नाइस. गुड गुड. घर वाला न्यू ईयर भी मना रहे हो तुम लोग अभी तो. गुड गुड, लॉन्ग ड्राइव एंड ऑल. अच्छा, मैं बिस्तर पे सो गया. ये कौन था? अच्छा. गजब गजब. हाउस पार्टी विद रिलेटिव्स. हाँ, रहने दो लक्ष्मी तुम. घर पे बैठ के पढ़ रही थी. तुमसे ना हो पाएगा. चलो, गुड गाइस. आई होप दिस हैज बीन like the past year has been an interesting year in terms of how things have gone by. Too much of uncertainty. Not that the new year has come with a lot of certainty, but yet we hope so. Things are going to be better, and we hopefully should get a chance to have offline classes. हाँ, बट ठीक है, अभी धीरे धीरे इसकी भी आदत लगी गई है. हाँ, लेट्स सी. हाँ हाँ, स्पेशली हाँ, जिनका ट्रैवल टाइम बहुत लगता था उन लोगों के लिए इट इज़ अ better option. Like you are able to save much on the time aspect. हाँ, ये देखो, ये पार्थ आ गया नोट्स मांगने. पार्थ, तुम्हारा नोट्स मांगने का सीन कब तक चलता रहेगा भाई? तुमको खुद से पेन नहीं चलाना है. ऑल राइट. नहीं नहीं, पेन तो तुम लोगों को थोड़ा बाद में चलाना रहेगा जब बाद में आई गिव यू द नोट्स टू कॉपी एंड मेक श्योर एवरीथिंग इज इन प्लेस. हाँ, नहीं नहीं, thermodynamics won't be that long as chemical bonding. So yeah, I generally teach at the Andheri Center, Andheri and Dadar primarily, but we don't know how things go in future. हाँ हाँ, tomorrow morning also we have a lecture, and we will be continuing with thermo only. थोड़ा सा टाइम हम लोग जरूर निकालेंगे फॉर बॉन्डिंग का डाउट डिस्कशन. सो अभी हम लोग थर्मो से स्टार्ट करेंगे. लाइक आई डिड नॉट वांट टू स्टार्ट द session with the doubt part itself. So I'll quickly take you through the basics of this new chapter, that is thermodynamics and thermochemistry. And then towards the later part of the class, we can also spend some time into doubts as well. नहीं तो एक बार कल का शेड्यूल आप लोगों को टाइम टेबल मिल गया है क्या अगले वीक का? हैव यू गाइस रिसीव द टाइम टेबल फॉर नेक्स्ट वीक? नॉट येट नो. हाँ, मुझे भी नहीं आया है, तो ठीक है. अदरवाइज अगर डाउट लेक्चर रहेगा, like last week was something which we didn't have the doubt lecture. Actually वो मेरा ही थोड़ा कुछ घूमने फिरने का प्लान्स थे, तो उसकी वजह से क्लासेस को रीशेड्यूल करना पड़ा. बट ठीक है, we will make sure that next week we do have a doubt lecture. नहीं रहेगा तो हम लोग अलग से भी कर लेंगे. ठीक है. All right, chalo, then let's begin today's session. We'll start with the thermodynamics and thermochemistry. Now, again, from the exam point of view, this is a very important chapter. In fact, you will also study about thermodynamics part in physics as well. अभी आपका physics में कौन सा chapter चल रहा है दोनों tracks में? Work, power, energy and optics. Okay. हाँ, तो इसके बाद आई थिंक देयर शुड बी अ पार्ट जहाँ पर थर्मो भी आपका शुरू हो जाएगा. हाउएवर केमिस्ट्री में हम लोग पहले स्टार्ट कर देते हैं थर्मोडायनेमिक्स, एंड something which will be very specific to chemistry that we will cover after some classes will be the aspect of thermochemistry, जहाँ पर we'll be applying the laws of thermodynamics on chemical reactions. Now हाँ हाँ, राइट. तो चैप्टर थोड़ा तो बड़ा है. इट इज नॉट as small as you might expect, like something like mole concept. It is relatively bigger. There are certain important concepts जिनको build करने में थोड़ा time लगता है. तो आप मान के चलो कि we will be starting with a conceptual bit first. आपको homework and numerical problem solving maybe I will be able to give you from second or third lecture onwards. Now what thermodynamics is, यहाँ पे notice करना, it deals with understanding of interconversion of various forms of energy when certain processes happen. For example, जब हम लोग gaseous state chapter के बारे में बात कर रहे थे, right, we had studied ideal gas and its properties, and we did take ideal gas into certain processes. Like we took ideal gas, we heated it or we compressed it, and while those processes were happening, we really didn't bother much with the energy exchanges. We were more interested in understanding, you know, these properties of pressure, temperature, volume, how they change. Okay. However, to demonstrate, these energy exchanges, I think I can share one quick example with everyone. Let me see if I can find a quick short video on it. I myself found it some years back. हाँ, but वो कुछ है interesting सा. Let me share with you guys. All right.
So, Nigel, what have we got here? Oh, we've got something called a fire syringe. And what does it do? Oh, well, I'll show you what it does. Some cotton wool in there. Okay. I'm just going to compress the air in it, and hopefully it will. I don't know what it's going to do. Wow. That's pretty cool. You made a spark in there. Was there any source of fire, like a match or anything down there? Well, as you can see, it's pretty transparent. There was no match in there. It was actually just the compression of the air on top of it, which was able to ignite the cotton wool that we had in there. So you're saying if we compress air, we can make it hot enough to ignite cotton? Yeah, because air is made up of particles. So when you're actually compressing it, you're forcing those particles to collide closer together, which is actually going to raise the temperature in the inside of that tube there. Okay, can you describe the apparatus for me? Well, all there is there's a glass chamber in there where the cotton wool sits. And as you can see, there's this piston that moves up and down into that glass chamber. And as it moves up and down, you can actually compress the air. So it's like a little plunger? Like a little plunger, yeah. Okay, so why don't we set one up so we can do it again? Do it again? Okay, I'll clean the remnants out. What are the tricks here? The trick is to get not too much, but not too little cotton wool. And it's good to get it aerated so that there's a lot of air around it, so it makes it much easier to ignite, just like a good fire. Is it just me, or do you feel like we're on a cooking show? I feel like we're on a cooking show, yes. Who do you think would be Jamie Oliver in this situation? Would it be you or me? I'm more manly, so... He's more like Nigella Lawson, let's face it. That's a good play on words. I wish. All right, we're ready for this? Yes. Simple as that. Obviously no matches, no switches, no anything. Okay. We'll try it. Again? You want me to try? You can try it. Yeah, do you have the strength? We're going to find out. We'll find out. This is going to be awkward. Derek, I think. Okay, so what I'm going to try to do is compress the air in there. And by compressing it, I'm going to increase its temperature because we're pushing all these air molecules together. And if I get it hot enough to the ignition point of cotton, hopefully cotton will catch on fire. Yeah, I've heard that the auto ignition temperature of cotton is about 400 degrees Celsius. So you can get quite enormous amounts of temperature from a very quick compression. 3, 2, 1. Surprise. Beginner's luck. Yeah, check that out. So I guess we could generalize and say if you...
All right, great. So I hope you guys got a good look at the experiment. It's a very simple setup. Like you took a gas and you applied a simple process over it, right? Like you just compress the air. ठीक है, यहाँ पर आप notice करना. I'll try and kind of give you a explanation behind. So there was some cotton which was present inside, right? And there was this plunger which was pushed inside, and it was pushed in a fast manner. The fast part is actually quite crucial. Like if you would try to do it in a slow manner, then it will not work. So what happened over here is that energy exchanges happened. What kind of energy exchanges happened? So someone, say the guy who was there in the video, he did work. He did mechanical work. Doesn't he pushed down this piston, and that resulted into heat. However, because the process was done fast, the heat didn't get much time to escape from these glass walls, and it rose the internal temperature. The internal temperature increased, and because of that, the cotton got ignited. If we do it slowly, then what happens is that that work gets time to get dissipated in form of heat from the walls of this tube. So that is why this fast played an important role. You could have done it slow as well, but then you would have required to kind of insulate this tube. You shouldn't allow any heat to escape. Then only the inside temperature will rise. No, there wasn't any vacuum. There wasn't any vacuum. It was some gas, like normal air, that was present inside it. Nothing special kind of air, like normal air also would do. Even normal air would do. There is no special kind of gas there that is present. So this was a simple experiment which demonstrates one of the key things that we were missing, or that we in fact didn't discuss in our gaseous state chapter. In gaseous state, we did discuss about gases, we did discuss about pressure, volume, and temperature, and how they change when we take gas from one state to another state. However, in this particular chapter, thermodynamics and thermochemistry, like we are going to study interconversion of various forms of energy. So this is where our now focus would be. ठीक है? हाँ, you will be able to answer this question, Pratmesh. So Pratmesh has a lot of questions. Like Harsh also has the same set of questions. Ki in case of slow, compression, then would it show the same effect? The answer is no, not really, because as I said, that if you do, push down that plunger slowly, then you will give the heat, adequate time for it to escape into surroundings. Here, what we did was we compressed it suddenly, and that kind of, led to this sudden increase in temperature. So yes, I'm sure that you guys have still a lot of questions as to what really happened, and that is the curiosity that we are really going to be working on in this chapter. Okay. So good that you guys are aware about this. Good that you guys are intrigued by this small setup, small experiment. Now, the modern day engineering, or lot of processes that happen around us work on these thermodynamic principles also. Like for example, the automobiles around you, their engines, the refrigerator around you, right, or air conditioner around you, they all work on these fundamental principles of thermodynamics. So these principles, they govern almost everything around us, and in fact is something which is a very robust concept in itself. However, as I said that we do deal with various forms of energy and their interconversion, but there will be certain limitations to this chapter of thermodynamics. And one such limitation will be that at our level, as per our syllabus, we will be focused on macroscopic level. Like we will be applying laws of thermodynamics on the bulk system. Right? So for example, you have solid, or you have liquid, or you have gas. We will have a sample of it. And on that sample, we would be applying these laws of thermodynamics, and not on individual particles. Now, this is something which is taken care in higher studies when we talk about statistical thermodynamics. This is not part of our syllabus, but I would really want you to be aware about it, that there is this branch of thermodynamics which goes into particle levels of details. What we have with us as part of our syllabus is the introductory concepts of thermodynamics in this chapter. Secondly, another important limitation that we'll be working with thermodynamics is that thermodynamics will not provide us any information regarding the rate of process or time taken for the process. So as a result of thermodynamics, as a result of the first law of thermodynamics or second law of thermodynamics, we will be able to understand, changes in energy, heat, work, temperature, all those things. But we will not be able to, get into the details of time taken. We do not get into this process of time taken because thermodynamics ke laws, they don't really tell anything. They don't tell us much about how fast or how slow processes happen. This is again taken care in another chapter which is called as chemical kinetics. This is again another branch of chemistry in which we discuss how fast or how slow a reaction would be, right? इस chapter में we can say reaction होगा कि नहीं होगा, that will be governed by thermodynamics, and reaction होने पर कितना heat release होगा या कितना heat absorb होगा, that is also thermodynamics. But reaction